Hello viewers, welcome to this video. Right, in this video I'm going to be showing you how to deploy a Kubernetes cluster to Google Cloud using the Hard Way documentation by Kelsey Hightower. So about a year ago I've done a couple of videos on Kubernetes the Hard Way. Maybe if I show you just me Kubernetes the Hard Way. Okay, so these are the three videos that I did on Kubernetes the Hard Way. These were based on LXC and LXD containers on my local machine. Two parts. The first part was theoretical, so I was explaining through my nodes what we are going to deploy and how every component, how all the components are interconnected and so on. And then we did the hands-on on the part 2 of this video. And also later, about a week later, I did another video testing the high availability of the cluster. So that was the video, and these videos were done about a year ago, and I wanted to give it another go, but this time not on my local machine but on Google Cloud. So this time, trust me, it's going to be very simple because I'm just going to follow the documentation that Kelsey Hightower wrote in his GitHub repository. So that's going to be a lot of copy paste, so it's going to be quite simple, unlike these videos where I need to do a lot of setup because I need to modify the documentation to deploy that in the LXD containers. Alright, so let's get started. Okay, let's search for Kubernetes the Hard Way, and the first one here by Kelsey Hightower, a GitHub repository. Okay, so prerequisites. So what we need a Google Cloud Platform account. So if you don't have one, sign up for a Google Cloud Platform account and you will get a $300 free credit. And he says the estimated cost is about 23 cents an hour, and we will tear this down. So it's going to take about an hour for me to, not an hour, don't get scared. We will be using less than an hour to try this out, and then we will tear this environment completely at the end. So you don't have to worry about if you've got a free credits, so don't worry. And then we're gonna install the Google Cloud SDK. I've got the Google Cloud SDK already installed. If I do GCloud version, so I'm on version 297 and the recommended version is 262. Okay, so before going any further, what I'm going to do is, instead of using the master branch, because this might change, so I'm going to go to the tags and go to 1.15.3, so that when you've got any questions or any comments on this later in the future, I can refer you to this particular tag. Okay, so yep, we are on 1.15.3, so you need to have a Google Cloud SDK installed on your Linux machine or anywhere, and the version has to be higher than 262, and the one that I've got is 297, so we are way newer. And set up the default compute region, compute zone. So follow this, but I've got everything already set up. So if I do GCloud configurations list, the default region for me is Europe West 2, and the default zone is Europe West 2A. So that's my Google Cloud account, the only account. So I've got another account, but I've deleted that just for the sake of simplicity. Okay, so I'm also gonna recommend you watching my video on setting up GCloud. So heading over to YouTube and searching for just me GCloud CLI. So you can either watch this video, Cube 27 GKE1, or GCP4, where I mention how to install Google Cloud SDK and how to connect your Google Cloud account. And if you want to connect multiple Google Cloud accounts in your GCloud CLI, then you can watch this video, GCP5. Okay, so those are the prerequisites. You need to have a Google Cloud account, install Google Cloud SDK, because we're not going to be using the Google Cloud Console, the web dashboard, but everything we're going to do is based on the GCloud CLI, which makes your life a lot easier. Okay, so the thing is, you install GCloud, you initialize your GCloud, make sure you can connect to the to your Google Cloud account, and then set your default region and default zone. That's it. And then we will be running a lot of commands in parallel on multiple master nodes and multiple worker nodes. So it is recommended to install tmux or any terminal multiplexer so that you can run commands in parallel. It's not a prerequisite, but it makes your life a lot easier. Otherwise, you will have to do the same commands repeatedly on different machines. So I've got tmux installed. That's it. So what basically we will be getting out by following this documentation is, one thing for sure, you will be learning the fundamentals of Kubernetes. So this is the best place to learn Kubernetes, because it's going to give you every single step involved in setting up a Kubernetes cluster and the different components that are involved in the Kubernetes cluster, like what components run in the master node, what components run in the worker node, and how these different components interact with each other, how to generate certificates. So the communication between different components is based on the certificate key pair and so on, and you need kube config file. So every single component like kube scheduler, controller manager, kubelet, kube proxy, in order to communicate with the API server, it needs to have the certificates, it needs to have the kube configuration file. So kube configuration file is the one that tells the component which cluster to connect to. So all the components talk to the Kubernetes cluster through a single entry point, which is the API server. So at the end of this process, what we will have is a Kubernetes cluster with 3 master nodes and 3 worker nodes, and all the components, including the commands that you type in your terminal, kubectl, will interact with this Kubernetes cluster through a load balancer. Because we have multiple master nodes, the entry point is going to be through a load balancer. All right. Okay, so those are the prerequisites, and then we go to the first step, installing the client tools. So we're going to be installing CFSSL, CFSSL JSON, 2 binaries to generate the certificates. Okay, so come down to Linux and just run this command, which I've already done. But anyways, let me do that again. So before that, let me go to my play directory. Do I have? Yep. So let me delete everything. Okay, so I'm on a clean directory here. I don't want to miss my home directory. Okay, so we are downloading these 2 binaries, setting the executable permission, and then moving them to user local bin. That's it. Okay, so enter. Okay, so now if I do which CFSSL, which CFSSL JSON, we have it. Okay, so CFSSL version, cool. Okay, CFSSL JSON version, so we've got everything running. Install kubectl. I've already got kubectl installed. If you don't have, just download this command, set the executable permission, and move it to user local bin. So I think, yep, so you will get a version 1.15.3, but the one that I've got is -- client. So I'm running the latest. I've downloaded the latest kubectl client 1.18.3, so I've got that. Okay, provisioning compute resources. So we've got all the prerequisites. Now it's time to provision the compute instances. Okay, the first thing we're going to do is we're going to create a VPC and subnets to run our Kubernetes cluster. So we're not going to use the existing cluster, but we're going to start everything from scratch. So if I do GCloud compute networks list, so it's going to list all the VPC networks that I've got in my Google Cloud account. So at the moment I've got VPC 1 and VPC 2. So yeah, so those are the 2 networks that I've got. And if you look in the subnets, GCloud compute networks subnets list. So I've got a couple of subnets in VPC 1 and 1 subnet in VPC 2, but we're not going to touch any of these VPCs or subnets. We're going to create one. So that's the command, copy and paste. All right, so that's done. And now if I do GCloud compute networks list, cool. So that's the VPC that we created, and the subnet mode is custom. So we didn't let the VPC create the subnets automatically. We want to create the subnets ourselves. So that's why we set the subnet mode to custom. So if you look in the option here, the subnet mode is custom because we want to create a subnet. So we're just going to create one subnet here with the CIDR 10.240.0.0/24. Okay, so let's create that. All right, that's done. And now if I do GCloud compute networks subnets list, we should have an additional subnet. Yeah, so that's the new subnet that we created, and that's the network range. Okay, so we are good now. And finally create some firewall rules. So the first one is the internal communication between the machines in the network, and then we will have the external access, SSH access, and so on. So basically we are creating it on the network, which is the VPC, and the source ranges allow it from everywhere. So the port is 22 and 6443 for the Kubernetes API server access. So first, let's verify what firewall rules we've got. So I'm doing all these before running every single command. I just do a list command to see what I've got already, because when it comes to cleanup, I will know what I had previously before following this documentation, and just wanted to make sure that it has, once I complete this documentation and after cleaning up, I'm left with what I had earlier. Okay, so GCloud compute firewall rules list. So the list of firewall rules I've got, so I've got just 2 firewall rules, one for VPC1 and one for VPC2. It just allows access on port 22 for all the machines that I've got in my 2 VPCs. Okay, so let's create these rules. Okay, that's done. Let's also create the other firewall rule. Cool, that's done. So now we can list the firewall rules. Okay, so we've got the external and the internal firewall rules. So that's good. Kubernetes public IP address. Because we are going to be using a load balancer to access the master nodes, we're going to reserve an IP address, which we will assign it to the load balancer in a later stage. So for that, we're going to create an address, and then we're going to see what IP address we've been allocated. So if I do that, cool, so that's going to be our public IP address which we have reserved, and this IP address will be attached to the load balancer later. Okay, so now comes the interesting bit, compute instances. The first thing we're going to do is we're going to create 3 master nodes, 3 compute instances to run our master nodes. And you can see here it comes with a boot disk of 200 gig, and we're going to be using Ubuntu 18.04 LTS as the operating system, and the machine type is N1 standard 1, and these machines will have the IP address 10.240.0.10, 11 and 12, because we are in a for loop, 0, 1, 2 and so on, and we are assigning the tag Kubernetes the hard way and the controller. Okay, so let's run that command. Alright, so that's complete, and now if I do GCloud compute instances list, we should have 3 instances. Yep, so we have 3 master nodes. Everything is N1 standard 1, and that's the internal IP address, and we also get the public IP address as well. So if you look here, the network IP is what we actually set in the for loop, 10.240.0.10, 11 and 12. So these are N1 standard 1 machines. I think these are like 1 CPU and 4 gig RAM or something. Let's verify. Machine types, N1 standard 1 is going to have 1 CPU and 3.75 gig of memory. Okay, so now comes Kubernetes workers. Again, the same thing. So now 0, 1, 2, this is again Ubuntu 18.04 LTS N1 standard 1. The only difference between the controller and the worker is this line here, metadata. So when we are creating these instances for the worker nodes, we are attaching some metadata to it. Metadata is like some information that you attach to the instances, because we will be using this metadata at a later stage when we are doing the when we bootstrap the master node, bootstrap the worker nodes. Because we need to specify the network IP range that the pods will be using. So for that we are creating this metadata, and we will use this metadata later while provisioning the Kubernetes worker nodes. And if you look at the private network IP, it's going to be 10.240.0.20, 21 and 22. So we have 10, 11, 12 for the master nodes, and 20, 21 and 22 for the worker nodes. Okay, let's go ahead and create that. Alright, that's done. So GCloud compute instances list. Cool. So we have 3 master nodes and 3 worker nodes, and if you look at the IP, it's 20, 21, and 22. All right. So we have that. Configuring SSH access. So let's try and log into our master node. When you're doing this for the first time, you will be asked to create an SSH key, and it will be uploaded to your project. Because I've already done that, it shouldn't be asking me for the SSH key to be set up. Yes. So it's not asking me. I'm directly logged into one of my master node. But if you're doing this for the first time after you created your Google Cloud account, probably you will be, yes, the screenshots here. So you will basically see these screens. It's up to you whether you want to add password to your SSH keys, and then you will be able to log in. Okay, so we are done with that step. Provisioning CA certificate. So now we're going to create certificate and key pair for various components that we will be deploying in our Kubernetes cluster. All right. So the first one is we're going to create the certificate authority. All right, that's done. And if I do ls-l, you have the configuration file. Sorry, I think I missed something I should be seeing. Okay, let's delete that and start everything from scratch. I think I missed something here. Yep, I think I missed this command here. Let's do that again. -rf./star. Yep, we don't. Oh, sorry. The problem is we just wanted to verify that whether we can log into the controller nodes. These commands should be done on the host machine. I've actually logged into one of the master nodes. So coming back out here, continue doing this on your host machine. So one thing you need to bear in mind is throughout this process, make sure you remain in the same directory, because this is where you'll be creating a lot of files, and we will be copying these files to different places. So make sure you stay in the same directory. All right. Okay, that's done. And if I do ls-l, cool. So we have this certificate and the private key. That's good. And now we're going to create the key certificate and key pair for the admin user. That's done. ls-l. Okay, so the certificate and the private key for the admin user. Now for the kubelet. And for the kubelet, we're going to create certificate and key pair for the kubelets running on each of the worker nodes. So we're going to be doing that for all the 3 worker nodes. So copy that, paste it. Okay, command completed. And if I do ls-l, cool. So worker 2, certificate, private key, certificate, private key, certificate, and private key for all the worker nodes. Right, so now for the controller manager, copy, paste, ls-l, where is it? Yeah, controller manager, certificate, and key. So now for the kube proxy, ls-l, yep, there we go, kube proxy, certificate, and key pair. And now for the kube scheduler, ls-l, we have it for the kube scheduler, certificate, and the key pair. And now for the Kubernetes API server. Okay, so now here, if you see here for the Kubernetes API server, the certificate that we are creating, it's actually here, the command to create the certificates. But under host name, you can see here 10.240.0.10, 11, and 12. So those are the 3 IP address of the 3 master nodes, internal IP address of the 3 master nodes. So we won't include that in our certificate because we are not accessing, we could be accessing any of the master nodes. So we need to make sure to include the IP address of all our master nodes for the Kube API server certificate, and also the public IP address which we reserved earlier, and also the Kubernetes host name, different host name through which we will access the API server. Okay, so let's create that. Okay, ls-l, Kubernetes, and the certificate and the key pair. We've got that. Finally, for the service account key pair, ls-l, where is the service account? Yep, service account certificate and key. All right, so now we're gonna we've generated all the certificates, all the certificate and key pairs for all the components, and now we're gonna copy this across to the worker nodes and the controller and the master nodes. First thing is we are copying the certificate key pair to all the worker nodes, and then we will copy them to the controller nodes as well. Okay, copy and paste. Okay, cool. So that's been copied, and now let's copy them to the master nodes. All right, so we've copied all the certificates that we generated to the respective nodes. Let's proceed to the next step. Okay, so now we are creating the Kubernetes configuration file. So we need to create the configuration file, which will contain kubeconfig file basically, which will contain the certificate for the corresponding component. And the kube configuration file is the one that tells each component where the Kubernetes API server is. So for that, we need to know the public IP address, because we will be using this public IP address in the Kubernetes configuration file that we're going to generate for each component. Okay, so first let's get that. Okay, and the kubelets Kubernetes configuration file. So first we're going to create the Kubernetes configuration file, kubeconfig file for the kubelet component for each of the worker nodes. So it's basically copy these commands. All right, so that's done. And if I do ls-l star config worker 0, worker 1, worker 2. So these are the configuration files, kubeconfig file for the kubelet components running on each of the worker nodes. And now for the kube proxy. And there we go. So we have the kubeconfig file for the kube proxy. Now for the kube controller manager. So we have that for the kube controller manager. Now for the kube scheduler, we've got that for the kube scheduler. Now for the admin user account, yeah, we've got the kube config file for the admin user account. Again, we're going to do the same thing. We're going to distribute this kube config file to the worker nodes as well as the master nodes. Yeah, that's done. And also to the master nodes. Cool, that's done. Let's proceed to the next step, which is to generate the data encryption config and key, because Kubernetes encrypts data at rest, so we need to generate the configuration. So that's the configuration file, and we need to copy this configuration file to all the master nodes, because that's where we will be running the HDD cluster. And okay, so once that's copied, we're going to move to the next step, which is bootstrapping the HDD cluster. So what we are doing here is we are going to bootstrap a 3-node HDD cluster, and these 3 nodes will be sitting in each of the master nodes. So we're going to be logging into each of our controller nodes. So I interchangeably say master nodes and controller nodes or control planes, so everything refers to the master node, right? Okay, so here we're gonna be logging into each of our 3 master nodes and then run all these commands in parallel. So what we're doing here is just bringing up a 3-node HDD cluster. Okay, so let me get my tmux and bring up a couple of panes, and let's resize it. Okay, and that one, yeah, that looks about right. Okay. Alright, so we're gonna log into each of the master nodes, and if I synchronize my pane, I can just type in one pane and then it gets replicated on all the panes. GCloud compute SSH controller, GCloud compute SSH controller 0, 1, 2. Cool. So we are now logging into each of the master nodes. We are logged into all the master nodes, and the first thing is we're gonna download the HCD binary. Alright, so that's done, and then what we're doing here is we're extracting the HCD tar file and moving it to user local bin. Okay, so let's copy that. Cool, that's done. So if I do which HCD, so we have HCD in user local bin, configure the HCD server. So what we are doing here is making the required directory var HCD, var lib HCD, etc HCD, and then copying the configuration files, certificates and everything, because HCD needs the certificate and key pair that we generated. Okay, let's copy that. That's done. Internal IP address, we are making that into a variable, HCD name. So basically HCD name is just the host name of each of these machines. And finally we are creating the systemd unit file. Alright, so that's done, and we're gonna because we have edited the systemd service file, we need to do a daemon reload, and then we are enabling the HCD so that it starts every time we start the machine. And finally we are starting the HCD service. Okay, let's do that. Alright, so remember to run the above command on each controller nodes. Yes, we have done that. Let's make sure that these services are actually running. Sudo systemctl status HCD. Yep, so HCD is active and running, and we're gonna do this command to make sure that things are happy. Just a quick verification. Yep, started, and everything is looking good. So one thing that's slightly different is, even in my testing it came up, if you look at the last column here, false, false, false. I don't know what that means, but here I don't see that output. But don't worry, in my testing it didn't cause any problems. Okay, so bootstrapping the Kubernetes control plane. So we've now got a 3-node HCD cluster. So don't log out, still logged into each of the master nodes. We're now going to bootstrap the individual master nodes. But again, we're going to do things parallelly to save some time. Make directory, etc Kubernetes config, and now we are downloading the binaries. The binaries we are downloading are Kube API server, controller manager, scheduler, and the kubectl. Okay, so let's download them. Alright, so that's done. Now we're gonna set the executable permission on all these binaries and move them to user local bin. Yes, just a standard practice. Which kubectl, we have kubectl, that's cool. Configuring the Kubernetes API server. Okay, so internal IP, we are taking that into a variable, and then creating a systemd unit file for Kube API server. Configuring the Kubernetes controller manager, and creating the systemd unit file for Kubernetes controller manager, and then the Kubernetes scheduler. So for scheduler we need a configuration file, which we are creating here, and finally creating the systemd unit file. Alright, so by now you should be knowing that we need 3 components in the master node, which is the API server, controller manager, and the scheduler. So we've created the systemd unit file for all these 3 services. Now we're going to enable them and start them. Allow up to 10 seconds for the Kubernetes API server to fully initialize. Okay, so I'm going to pause the video and come back after 10 seconds. Yep. So now let's verify if all of these services are looking okay. Sudo systemctl status Kube API server, that's active and running. Sudo systemctl status Kube scheduler, again active and running. Sudo systemctl status Kube controller manager, again they're all running fine. Okay, so now we are going to enable Hosta TP health check. So what we are actually doing here is we are going to install Nginx, and we're going to use Nginx as a proxy service. So, okay, let me explain to you what we are actually trying to do here. So we have 3 master nodes, right? And we're going to set up a load balancer shortly, and all the interactions to the cluster will be through the load balancer. So as a standard practice, any load balancer, it needs to do a health check on the underlying instances. So it only allows traffic to the instances that are healthy. So we need to define a health check to make sure that our Kubernetes API service is actually running. So we don't want to send the traffic to a API server or the master node where the API service is having problem or is not running or something. So we need to define a health check so that the load balancer knows which nodes are healthy and which nodes to send traffic to. So in order to create a health check service, we need to make sure that a service, the process is running on 6443 and the nodes are listening on 6443. So we know our Kube API service is running on 6443 port. So we need to make sure it's running on that on HTTPS. But we're going to be using network load balancer, which doesn't support HTTPS. So we can only check the HTTP health check as an endpoint. HTTP as a health check endpoint. So that's why we're doing a little hack here, which is like installing an Nginx reverse proxy, and we are exposing that to port 80 so that load balancer can check the health endpoint on the port 80, which is allowed HTTP, and internally this Nginx actually does a proxy to 6443. So when you hit port 80 on any of the master nodes, it's gonna take you to 6443 reverse proxy. So that's what we are actually doing here. So let's install Nginx. Alright, so Nginx installed. So now we're gonna copy this configuration. So it's just a simple configuration, listening on port 80 and then proxying it to 6443 internally, and also set up the sites available and restart Nginx, and we also need to enable the Nginx service. Alright, cool. So now let's do a quick testing. So verification, kubectl get component status, and we are passing the kubeconfig file admin.kubeconfig. So if you look at admin.kubeconfig file, so the server is basically the local host and it's called port 6443. Okay, let's do a quick testing. kubectl get component status. Alright, so you can just do it in one server, but since I've got the pane synchronization enabled, I ran it on all the machines. So all these components are looking healthy. We've got the controller manager, we've got the scheduler, and all the HCD nodes on these master control planes are looking healthy. Cool. So we also do a curl command to make sure that we get a 200 response. Yes, HTTP 200. Okay, so basically we are looking up the health check endpoint 127.0.0.1/:80. So which is the HTTP endpoint the load balancer is going to check, and RBAC. Okay, so this needs to be done just on one machine. So I'm going to turn off the pane synchronization. Okay, so role-based access control, we're going to create a cluster role and a cluster role binding. I missed it. Okay, so we've created a cluster role called Kube API server to kubelet, and we're also going to create the cluster role binding. So make sure you run these commands just on one node. You don't have to run it on all the other nodes. Kubernetes front load balancer. Okay, so we've configured, we've provisioned, and we've bootstrapped all the master nodes. So now it's time to provision our load balancer, Google Cloud Load Balancer. So it involves a few steps. So first we're gonna know the public IP address. If you remember in the first step, I mentioned when we were creating the worker nodes, the difference that I mentioned is the metadata field where we added the pod CIDR. So here we are getting the pod CIDR range. Where is it? No, sorry, it's not here. Sorry, ignore that. So it's during the worker node provisioning, not here. Okay, so for creating the network load balancer, we need to know the public IP address that we actually reserved. Yeah. So again, all these commands, just do it on the host machine, not on any of these machines. So I'm going to exit out of all the master nodes. Okay, so I'm back on my host machine. So make sure to run the following commands on your host machine, not on the master nodes. So what we're doing here is we are creating the health check endpoint. We are creating the firewall rules to allow Google servers to do the health check on our API servers. We create the target pool. We add all our master nodes to the target pool. And finally, we add the target pool to the load balancer. So all these steps will create the load balancer and all the services. Cool, so we have our load balancer created, and let's do a verification. So for that we need to grab the public IP address that we reserved during the initial stages. So that's going to be our public IP address, and if I do echo $.1 Kubernetes public IP address, it's not there. Hang on, yeah, I missed the final yes. Okay, cool, so that's our IP address that we reserved for our load balancer. Now let's do a curl command to, actually I think it has put some extra backslashes. Alright, cool, so I think we got the same result as in this documentation. Okay, cool, so our master nodes are all working fine. We've bootstrapped all the master nodes, HDD nodes. Now it's time to configure the worker nodes. Okay, again, we're going to be logging into each of these worker nodes and going to be running the commands in parallel. So let me bring up my tmux. Okay, I'm already in the tmux session. Let's create a couple of windows and resize it. Now the other way. Okie dokie. Alright, let's log into each of those. GCloud compute SSH worker 0, 1, 2. Alright, so let's log into all our worker nodes. Worker 0, worker 1 and worker 2. So the first command we're going to do is install some OS dependencies. And then we're going to disable swap. This is just swap on minus yes or minus show. It's just going to tell you whether swap is enabled or not. But anyways, let's disable swap. Alright, so turning off swap, and we're going to download all the required binaries. So basically CryptCTL, runc, CNI plugins, containerd, and then kubectl, kubeproxy, and kubelet. Let's download all of them. Cool, so all the binaries downloaded. Let's create some required directories. That's done. Install the worker binaries. Basically we're extracting it, setting the executable permission, and moving it to the bin directory. Alright, so that's done. And finally configure CNI network and pod network seeder. Okay, I think, yeah, this is where I was actually talking about. So pod seeder. So we need to find out what's the pod seeder is. So basically we are accessing the metadata pod seeder. We are sending it to the pod seeder variable. So metadata.google.internal. So that's the pod seeder metadata that we attached to each of the worker instance when we created. So we are grabbing that now. And if I do echo $pod seeder, yeah, so all the pods that get launched in the worker 0 will be in this range 10.200.0.0/24. And the one in worker 1 will get the IP address in this range 200.1.0 and 200.2.0. So that's the pod network seeder range that we stored in the metadata information on all these instances, which we are now retrieving it and storing it in the pod seeder. Alright, so creating the bridge connection and the loop back. Containerd. Alright, so plugins and the systemd unit file for containerd, configuring the kubelet, copying the certificates and the kubelet's configuration file, and the systemd file for kubelet, kubeproxy, kubeproxy's configuration, and the systemd unit file for kubeproxy. And finally we're gonna enable and start all the services. So basically in the master nodes we had 3 services: Kube API server, Kube controller manager, and Kube scheduler. In the worker nodes we have 3: the containerd daemon and the kubelet and kubeproxy. So we're gonna enable and start all of them. Okay, so that's done. And now before doing this command, let's verify if all these services are running. Sudo systemctl status containerd, that's up and running. Sudo systemctl status kubelet, that's up and running. Systemctl status kube proxy, that's also running. Cool. So everything is running fine. So we've completely bootstrapped all our worker nodes. So we're going to do some verification to see if we can see all of our worker nodes are ready. So I'm going to exit out of all the worker nodes. And I'm going to log into one of the master node. It doesn't have to be controller 0. You can log into any of the nodes, controller 0, controller 1, or any of the master node, and basically run this command. Okay, so what I basically did was I logged into the controller node from controller 1. Okay, anyways we got it actually. Okay, right. GCloud compute SSH controller 0. What I basically did was I didn't realize that this command actually has the SSH to controller 0. So I initially logged into controller 1 and I ran this command. So from controller 1 to controller 0. So that's why it ended up creating a new SSH key pair. Okay, so we are good. So configuring kubectl for remote access. What we are basically doing here is we're going to configure our kubectl, the machine that we are in. So my host machine here, I've got kubectl, but if I do kubectl cluster info, it doesn't know which Kubernetes cluster to connect to. So that's what we are trying to sort out here. So if I do ls.kube, I've got a .kube directory under my home directory, which will get created automatically, but I don't have any configuration file. So that's what we are going to do here. We're grabbing the public address of our load balancer, and then we are setting the context. By doing this, it will create a Kubernetes configuration file, which we can then use to connect to this Kubernetes cluster. So now if I do ls.kube, so you have this config file, and if I open up that config file, so that has the information about which Kubernetes API server that I'm talking to. So I can now do kubectl cluster info from my local machine. Yep, that's running fine. Kubectl get nodes. We have 3 worker nodes. Cool, so everything is fine. Kubectl version -- short. So server version is 1.15.3, which is the tag that we used for this GitHub. Okay, so everything is okay. Provisioning pod network root. So what are we trying to do in this step? So at this point, I'm not going to do the testing because I already did the testing, and I've also shown you how to do it in my other Kubernetes The Hard Way video, which I did about a year ago. Basically, at this point, if you create pods, the pods in one nodes won't be able to talk to the pods on the other nodes. So basically, we need to set this static routes on all our worker nodes instance. We are basically enabling the pods in a node talk to the pods on the other node. So once we do that, the pods can talk to other pods on any other nodes. At this point, it won't be able to talk to the pods running on the other nodes, but that's what we are going to fix. I would advise you to just give it a try. Just create a couple of pods, a busybox container, get a shell into those busybox container, and make sure they get launched on different worker nodes, and then try to ping each other. They won't be able to talk to each other. So once you create this route, then you will be able to do it. So first command, we are just trying to find out what's the IP address of the node and what's the corresponding network range for the pod sitter. Okay, so we've got that, and run this command to add routes. All right, so routes have been added. Now we can list the routes. Yeah, so we've got all the routes defined, and now we're going to deploy the cluster DNS add-on. Just a simple kubectl apply, which you can do it from your host machine because you've got access to the Kubernetes cluster with your kubectl. So it has created a service account, core DNS service account, cluster role binding, and other things. Okay, kubectl -n kube system get pods. So that's core DNS. They're all running fine. Verification. Okay, let's quickly deploy a busybox container. Kubectl get all. So the busybox container is getting created. We are just testing by just creating a simple pod. Kubectl get all. Our busybox pod is running. So now we're going to grab the name of the pod. Pod name is kubectl get pods, and yeah. So instead of typing the pod, we are just using the command to store that in a variable name, and then we're going to get a shell into, not actually a shell, but we are just directly going to run the command inside the pod. NS lookup Kubernetes. So we're just doing an NS lookup on Kubernetes and seeing whether we get the response back. If we don't get the response back, then there's some problem with the DNS cluster add-on. I don't see any problem because you get the response. You got the response back 10.32.0.1, which should be the same as kubectl get service. Yeah, that's the Kubernetes service 10.32.0.1, which means our cluster DNS add-on is working fine. All right, going to smoke test. I'm not going to do this data encryption thing. If you want, you can just follow this, and we're going to create a simple Nginx deployment. Kubectl get pods. Our Nginx pod is getting created. Get pods. Okay, let's leave that. Okay, port forwarding. Kubectl get pods. Okay, cool. So now our Nginx pod is running. We are going to see whether we can access the pod. Pod name again, getting the name of the pod into a variable, and then do a kubectl port forward. Okay, so if I open up another tab and go to localhost colon 8080, we should be able to see the Nginx welcome page, which we can. Cool, so port forwarding is working fine. And I've closed the port forwarding command, but if you are still running, then you can do this curl command. It's basically just to verify that you are getting the 200 OK response back. All right, so logs, kubectl logs pod name. Yep, so we can access the logs, and looking at the version of Nginx that's running 1.19.0 services. Okay, so now what we're trying to do is we are going to try and expose this. We only did the port forwarding, we didn't expose it as a service. Now let's try and expose it as a node port service. Okay, kubectl get all. So we have our Nginx pod running, which has been exposed as a node port service, and the node port is 30112, and we're going to grab that into a variable. And if I do echo $node port, it's 30112. We basically got this into a variable, and so we need to add this into our firewall rule, because at the moment, if I try to access from my machine any of the worker node, worker 0, worker 1, or worker 2, because by this time you should be knowing about the concept of node port. It doesn't have to be, so the pod is, it can run on any of the worker nodes, and you can hit any of the worker nodes on this particular port, and then it will forward you to the nodes where the pod is actually running. So if I do kubectl get pods -o wide, so if you can see here, the Nginx pod is running on worker 0, which means I don't actually have to hit worker 0 on this port. I can hit actually any worker node, worker 1 or worker 2 on this port, and I should still be able to access it. So that's node port. So for that, we're going to create a firewall rule. This firewall rule is for external IP. Okay, so we are grabbing the external IP of worker 0. Okay, so we're basically going to connect to worker 0, and if I do curl IP, for my ZSH is putting some extra characters whenever I paste some special characters. Okay, so 200 OK response, that's fine. Cleaning up. Okay, I think at this point we are done with our Kubernetes the hard way. If you want to play around, we can play around, but I'm gonna tear everything down. Okay, so that's all I wanted to show you. Now it's time to clean up our environment. So we need to clean up all the VPCs, subnet, firewall rules, instances, load balancer, and everything. Okay, the first one we are going to do is delete the controller and worker compute instance. Okay, so that will get rid of our 6 instances that we've got. All right, so that's done. If I do GCloud compute, come on, compute instances list. All right, so all our nodes, worker nodes and master nodes have been deleted. So now we're going to delete the load balancer, target pool, health check, and so on. And after that, we're going to delete all the firewall rules, and finally the static routes that we created on all our worker nodes, and then the VPC and the subnet. Sorry, the subnets and then the VPC. If you try to delete the VPC, I think it should also delete the subnets underneath it, but I don't know. Okay, so that's done. Deleting the firewall rules, that's done, and deleting the subnet and VPC. Cool, the command completed. I'm just going to quickly do a couple of checks to see that it has deleted all the resources. I've already tested, I've already verified that it has deleted all our instances. GCloud compute firewall rules list. So I had 2 firewall rules. Yes, that's looking good. GCloud compute networks list. Okay, so I'm back to 2 VPC. Okay, cool. I think that's all I wanted to show you in this video. I'm very sorry that it took so long. I think it took about 52 minutes. I didn't expect it to take this long, but actually the good thing is you tend to learn a lot by doing this practice. So if you've got any questions or any comments, let me know. I'll be happy to help. And don't forget to subscribe to my channel, and I will see you all in my next video. Bye-bye.